So we're back into question three. It's not the same room, not the same day. But we're back into question three. There's two parts of in question three for the same year. I think it was 2016, 2017. So there will be two parts for this question. We'll go first into part B of the question because I feel it's the most hard, the most new part of the calculus and vectors because the most of it I think probably everyone probably everyone did it in either in high school, A level, or something. So the second question says consider transformation, and they gave you. I will try to write it here because it's not the same room, so there won't be enough space. Not like yesterday. Yesterday the room was awesome. The two cosine of theta. That's with the x, and then with the y is 3 r sine of theta, and you have x squared plus y squared is equal to 1, and x squared is divided by 4, y squared divided by 9, and this is the enclosed curve. That's the area that we want to work on. So this is the area that we want to work on. So it's x squared plus y, x squared divided by 4 plus y squared divided by 9 is equal. One of them, please work. One of the pen, please work. X squared plus, okay, I'm gonna stick with the black pen for now. X squared divided by 4 plus y squared divided by 9 is equal to 1, and we want to show the first part of the question is show that the Jacobian, this is the Jacobian, is equal to 6r. But I will teach everyone, as in the beginning, what does a Jacobian mean. So imagine if you have an area of x and y like this. So you have this area, and this is x-axis and this is the y-axis, and maybe it looks something like this into one coordinate system. But then somehow you change the coordinate system into a new coordinate system, for example u and v, and this area become a nice area. And you want to integrate over this area. So instead of integrating over this messy area, you will go to this area and you want to integrate over this area. To be able to do it, first thing you change the boundary. So you need something like a coefficient for the changing for this one. So you need a coefficient for this thing to happen. This coefficient is called the Jacobian. So we need first thing to integrate it over this thing. We change the function, we change the boundary as you see, and you need a Jacobian to relate those two boundaries. So first thing in this question, this is what we're doing actually in this kind of question. What is Jacobian? Jacobian is just a transformation between one coordinate system to another. So once you transform the area from one system to another, the shape of the area will change, as we see. So this is in the x and y axis. It's x squared plus y squared, x squared divided by 9 plus y squared, x squared divided by 4 plus y squared divided by 9 is equal to 1. And this thing will be an ellipse in one of the coordinate system. It will be an ellipse of radius x, not radius, sorry. It will be an ellipse with the equation x squared divided by 4 plus y squared divided by 9 equal to 1. This is in the first coordinate system. And we will see how it's gonna look once we convert it into the other coordinate system. But before that, we need to find the Jacobian. So we start dx divided by the first coordinate system, the first thing in the second coordinate system. So in the first coordinate system, the variable was x and y. In the second coordinate system, the variable was in terms of r and theta. So you start with the first. Second doesn't matter because matrices will give us the same thing, because we're just talking about also the module, so it will be the same thing. So you differentiate the first thing with respect to the theta, and you differentiate again the first thing, but this time you differentiate with respect to r. Then after that you differentiate the second thing, the second variable, with respect to theta, and differentiate it then with respect to r, and those curly d mean we're actually taking the partial derivative. So I will do one of them to see that. So dx with the partial derivative of x with respect to theta will be equal to negative 2r sine of theta, and so on will goes for the other stuff. So this thing will goes for all of them, and we will find that after simplification we'll find that the answer should be similar to the given answer. So I'm gonna do it fastly. Dx divided by dr will be, in this case, will be equal to 2 cosine of theta, dy divided with respect to the partial derivative with respect to theta. This is also a good exercise for doing the partial derivative. So 3r cosine of theta, then dy divided with respect the partial derivative with respect to r for this thing will be equal to 3 sine of theta. So you multiply dx by d theta, you take the determinant, so you multiply the diagonal, the main diagonal, and you subtract it from the other diagonal. Dx with respect to d theta will be this thing, times dy with respect to dr, dy with respect to dr is this thing. No, d with respect to r is this thing. I was like saying what's going on. I guess it should be those two together. Then you subtract it from this multiplication from those two together. So the answer should be equal to 6r, because it will be cosine square plus sine square with the negative for all of them. So it's negative parentheses cosine square plus sine square, which should be 1. And the modulus of negative 1 times negative is negative 1. The modulus of that will be equal to 1. So the answer will be left as 6r. So that's the first thing in order to evaluate this Jacobian or this problem. The second thing is you have to change the boundaries. You have to so right now in the old coordinate system, the structure used to be an ellipse, and once you plug the x values as r and theta as in function of r and theta, and the y values as a function of r and theta, you will get that. So we will work it together. We will get that r square cosine square of theta plus r square sine square of theta is equal to 1, or r square is equal to 1. So this thing is actually a circle in the polar coordinate. So this thing is actually a circle in the polar coordinate, and you have the Jacobian. And if you want to change the boundaries in this question, the question was the curve was enclosed by this thing. So the area was an ellipse in the old coordinate system. In the new coordinate system, the area will be a circle of radius 1. So we will change it into 6r dr d theta, because from dx dy you change it to dr d theta, the new parameters, and because there's r and theta, we expect it to be in a polar coordinate system, and the 6r is the Jacobian. So what's the Jacobian? So the Jacobian is a transformation factor. So in all coordinate system, it will be dx dy for the area. For the new coordinate system, it will become the Jacobian du dv. In our case, u is r and v is cosine of theta, or the other way around, doesn't matter, because you set the boundary based on them. So for r, we can choose r to go from 0 to 1, and for theta to enclose the whole thing, we'll choose it to go from 0 to 2 pi. The last thing that we have to do in those kind of questions is to change the function, because the function will be in terms of, so we found the Jacobian, we change the boundaries, and you saw what's the graph gonna be based on the graph, or based on the, say it will be either graph or a circle. This is the exam. Maybe we're gonna be a graph or circle, or it's gonna be two line, like it will be a rectangular region. So if it's a graph or circle, we saw that this is gonna be something in a polar coordinate. So always, like, if a circle is always gonna be in polar coordinate, r squared is equal to something, and you just find it out. So the last thing, you want to find that y squared. Y squared, we just square this thing, so it will be times 9 r squared sine the square of theta multiplied by 6r dr d theta, and you first evaluate dr and then evaluate d theta, and after, like, the first evaluate dr, then you evaluate d theta, and the question is over. So it became first those question. It is showed that the Jacobian, with the Jacobian you just apply the matrix dx d theta, dx dr, dy d theta, dr, dy dr, which is theta and r is the new variable of the new coordinate system, and x and y is the old variable in the old coordinate system. You find that, then you get some value, you always take the absolute value of that thing. Then it goes from dx to dy, it will go to d, the new coordinate system variable, and the new coordinate system variable, so it will be dr d theta, but don't forget to multiply by the Jacobian. You change the boundary, you change dx dy, last thing, put y with the value of y squared, put in the function, and the function will be an easy function that you can actually evaluate it as a double integral. This is question B from the third question. Then right now we're gonna go to the question A from the third question.